Hello, Math 7 students. These are the notes on ratio and rates, the first notes that we're doing with Unit 4. So starting off with our essential question, how can ratios and rates be used in everyday lives? So first starting off with the definition for ratio. A ratio is a comparison of two numbers by division. So there's a couple ways you can write a ratio. So for example, if I'm comparing two numbers, 2 to 5 would be an example of a ratio. I can also write this as 2 with a colon. 5, that is still considered a ratio. We would still read that as 2 to 5. And then the last way to do it is as a fraction. And this should look familiar to you guys because we've talked quite a bit about the fact that fraction bars are division problems as well. So some important things to note about ratios. When you're talking about ratios, you have to make sure the numbers you're comparing have the same units. And you have to make sure that you use integers. There are no decimals or mixed numbers. When you're writing a ratio. Now, a rate is the same thing as a ratio. It's a ratio with different units. So, for example, something like 60 miles in 2 hours would be a rate. If you kept track of your math skills, solving 3 equations in 2 minutes would be an example of a rate. Going back to the ratio slide, when we're talking about 2 to 5, you would be comparing things that have the same units. So 2 boys to girls. I'm talking about gender. 2 green Jolly Ranchers to 5 red Jolly Ranchers, those kinds of things. So the first example is talking about finding ratios and rates. So there are 45 males and 60 females in a subway car. So if we're talking about highlighting important information, I would circle those numbers, and I'm going to draw arrows so that I remember what those numbers are talking about. And let's see, the subway car travels 2.5 miles in 5 minutes. So it says find the ratio of males to females. Now this is really important because it said males first, then females. So there are 45 males to 60 females. But we always like our ratios to be completely simplified. So if I look at this as a fraction, 45 to 60, both of those values can be divided by 15. And 45 divided by 15 is 3. 60 divided by 15 is 4, so our ratio is 3 to 4. And I'm going to put quotation marks in here. This is how we should read that fraction. We're not going to say 3/4, we're going to say 3 to 4 because we're making a comparison. Now when it says find the speed of the subway car, it's really asking us to find the rate at which the car is moving. So the car is moving 2.5 miles in 5 minutes. And if you have a calculator handy, you can go ahead and divide those two and get that it's traveling 0.5 miles or half a mile per minute. So every minute it goes another half mile. Again, just to highlight the differences, for the rate problem, we are talking miles compared to minutes, but in the ratio problem, we're talking males to females. So yes, of course, one is boys, one is girls, but we're talking gender altogether. That counts as one label. Now, in the last example on the page, we want to find a rate from a table. So the table shows the amount of money you can raise by walking for a charity. Find your unit rate in dollars per mile. Now, I know in some classes we've talked about per. Per means to divide. So what this is really saying is take your dollars and divide it by the number of miles. So here's your dollars. Here's your miles going across the row. So for each one, if I take the dollars, so let's start with $24 and divide it by the miles, 24 divided by 2 is $12 per mile. Same thing with 48 divided by 4. 48 divided by 4 still gives us $12 per mile. 72 divided by 6, and again I'm just getting these numbers here. 72 divided by 6 again gives us $12 per mile. Now we should see a pattern here, the 96 and the 8, I'll let you do that one on your own, but it should come out to be $12 per mile. So our unit rate is just that, $12 for every mile that we walked. So lastly, at 7 a.m. it is 30 degrees Fahrenheit. At 3 p.m. it is 40 degrees Fahrenheit. What is the rate of temperature change in degrees per hour? So degrees per hour means degrees divided by the number of hours. So the total change in degrees at 7 a.m. it was 30 degrees. It was 40 degrees at 3 p.m. So that's an overall temperature change of 10 degrees. And we're going to divide that by the number of hours. So from 7 a.m. to 3 p.m., that is 8 hours. So 10 degrees in 8 hours. To find the rate, we divide. 10 divided by 8 is 1.25 degrees per hour. For every hour, that's how much the temperature dropped.